Hello, welcome back to the revision series. Maths again today, and a really big one. One I haven't been putting off, but I know it's a super important one today, and that is multiplication, specifically long multiplication. I don't know why I've been putting it off. I think it's because so many people struggle with it. I've been trying to organize it in my mind how I'm going to best explain it, but here we go. So, very important. It is, unfortunately, there's no shortcut to this. It is firstly all about your times table knowledge. If you have that, it's going to free up your working memory. You're going to be able to hold part answers in your head. It's going to make things a lot easier. I will keep going on about the importance of times tables, but they just are fundamental. So we can't move around that too much. Secondly, it's fundamental in all arithmetic and reasoning papers. You're going to be asked in multiple different ways through primary school into secondary school, all the way through secondary school. You're going to be asked to show how you multiply. So if we can get it sorted now, we can turn a weakness into a strength with relative ease. I'll show you how I do it today. It is worth your time to learn and understand. The way I'm going to do it today is start off with a simple question, build up the complexity, but hopefully you'll realize that actually the method doesn't change that much. We're just doing more small bits of multiplication. It doesn't fundamentally change when we're multiplying a 3-digit number like we are here by a 1-digit number, 4-digit by a 2-digit, or anything in between. So let's have a look at this one. Firstly, don't get thrown off by the fact that your answer block is on the left and your question is on the right. Our equal sign means these two things are equal, so we can write them in whatever way we would like. Writing things neatly is really going to help when we have some more complicated questions, but my minds are never that straight. Here we go. 6 times 7, 42. So exchange the 4 over. We can't fit both of those digits in this box. 7 times 9, 63. Add the 4, 67. 6 goes over here. The 7 goes there. 7 times 5 is 35. Add the 6 is 41. 4172. You can write it in that box if you like, gold standard. Make sure it's nice and clear. Okay, so we can see here that we're just taking this number that we're multiplying everything by, the 7, going there into the ones, there to the tens, there to the hundreds. This will make more sense as we're getting into the more complicated questions. Here is one. 2 marks for this. That is why it's crucial to get this right. If we can just turn this into a strength, we can chew up some marks. Let me highlight what we're actually going to be doing here. So our first calculation is going to be doing that times that times that, and that times that. And I'll show you what I mean when we get going. So actually I write this at the beginning. It's making it a little bit difficult to read, but I'm actually going to separate it into 836 times by 7. And I do genuinely write this to the side of all my calculations. Underneath, I'm doing 836 times by 20. Together, we have 20 and 7, 27. So it is important to know what we're doing it for. And we go through the same method here. 6 times 7, 42. 4, carry the 4, keep the 2 there. 7 times 3, 21. Add the 4, 25. 7 times 8, 56. Add the 2, 58. Now I could draw it down here like we would usually, but I'm just going to bring that up anyway. So now we have 5,852 for the first bit. The reason I write this 20 and I remind myself to do this every time is I'm going to have to put this here. Some call it the magic 0, but this has to start with a 0, and we're going to realize why once I rub off the yellow highlighting. We need to know that what we're actually doing in this section here is multiplying 20 by 6, 20 by 30, and 20 by 800. That's the calculation we're doing. So we've done 7 by everything. We're now doing 20 by everything. So 20 times 6, what we're seeing it as is 2 times 6. But you see that 6 lots of 20 is 120, 1, 2, 0. So you can see why we always have to have a 0 there. We're multiplying by a double-digit number. So it's always going to be a 0. 6 times 20 is 120. But we can just view this as 2 times 6 and carry on as we were. 2 times 3 is 6. Add the 1 is 7. And you're going to notice we're offset. Whereas when we were doing the ones, we were writing our answers directly below. Now we're writing it off one line. So don't think you have to draw it exactly underneath. 2 times 8 is 16. And I would be writing it like this, but I would bring the 1 straight up. Actually rubbed off some of my answer there. Sometimes 642. If you get to this stage, you've got 1 mark. So we just don't drop it at the end. We're nice and clear. We've left room to exchange. Now we're just adding. 2 add 0, 2. 5 add 2, 7. 8 add 7 is 15. 5 add 6 is 11. Add 1 is 12. 1 and 1 is 2. 22,572. 22,572. So hopefully that's explained why it's set up as it is. And now the only thing that's going to be different in any other questions, certainly in primary and early secondary school, is you're going to have another number up there in the thousands column. The method's no different. You're just doing 1 more multiplication at the end and then another 1 more multiplication at the end. But the method is the same here. You're doing 2 different lines here. And now we move up to the hardest things you'll find in terms of long multiplication in primary school is something like this. The method remains the same though. 3, 4, 6, 8 times 2. In brackets, so you remember what you're doing. Down here, 3, 4, 6, 8 times by 60. Now I'm never going to forget to put that 0 in. 2 times 8, 16. 2 times 6, 12. Add the 1, 13. 2 times 4, 8. Add the 1, 9. 2 times 3, 6. That's the first half done. Remember, we have to put a 0 in here because we're not actually multiplying everything by 6, or that will seem that way. We're actually multiplying all these numbers by 60. We've reminded ourselves here. 6 times 8, 48. 6 times 6, 36. Add the 4 is 40. 6 times 4 is 24. Add the 4 is 28. 6 times 3 is 18. Add the 2 is 20. You would draw it down like that, but you can just draw it straight in there. 208,080. Not bad on the straight line front. We're getting there. We would get 1 mark if we get to this stage, but we can close it out quite easily. 6 add 0, 6. 3 add 8, 11. 9 add 0 is 9. Add the 1 down here is 10. 6 add 8, 14. Add the 1, 15. 0. Don't forget the 1 down there. 1, 2. 215,016. 215,016. Again, doing the 1s column by everything, and then in a different line, we're doing the 10s column by everything across there. Making sure we're nice and neat, making sure our exchanging is correct, making sure it's nice and clear and we don't forget anything at that final stage. As I said, this is the hardest of arithmetic that you're going to get from multiplication. It is worth 2 marks. It's only long division and long multiplication that you get 2 marks for, so you might as well make it count and turn it into a strength. Okay, let's tackle a tricky one. Here's from a reasoning paper. Layla makes jewellery to sell at a school fair. Each bracelet has 53 beads. She makes 68 of them. Each necklace has 105 beads. She makes 34 of them. How many beads does Layla use altogether? So we've got a couple of multiplications here. 53 times by 68. And I'm going to put down the side 53 times by 8. 53 times by 60. 8 times 3, 24. 8 times 5 is 40. Add the 2 is 42. Now we're doing everything by 60, so I'm going to put my 0 in there. 6 times 3 is 18. And 6 times 5 is 30. Add the 1 is 31. Add these up. 4. A 10 there to add 8. 4 add 1 is 5. 6 and 3. So we've got 3604. I'm going to put that up there for my final calculation because I've done the bracelets. Next up, we have necklaces. 105 times by 34. Oh, that's a dreadful line. 105 times by 4. We're going to go with it anyway. I'm going to have to move some space down here. I am actually going to have to get rid of that. That is actually unacceptably wonky. Oh, look at it. It's beautiful. Okay, 105 times 4, and then it's actually 105 times by 30. Let's go then. 4 times 5 is 20. 4 times 0 is 0. Add the 2 is 2. 4 times 1 is 4. Put a 0 in here. 3 times 5 is 15. 3 times 0 is 0. Add the 1 is 1. 3 times 1 is 3. Add them up. 0, 7, 5, 3. 3,570. 3,570. All I need to do now is, because I've got the necklace numbers, I've got the bracelet numbers, add them up. 4 add 0 is 4, 7, 6 add 5 is 11, and 3 add 3 add 1 is 7. 7,174 beads. So you'd likely, I haven't seen a mark scheme for this in a while, you'd likely get 1 mark for getting the number of bracelet beads, you'd probably get 1 mark for getting the number of necklace beads, and you'd get a 3rd mark for getting the total number. Well, you'd get the 3 marks for getting the final answer, however you got it, but we always show our method as we're asked to, so that if something goes wrong midway through, we can gather up as many marks as we possibly can. And that's how we would tackle a reasoning question that is purely focused around multiplication. Remember that a big multiplication, big number, is fundamentally the same as a small one. Once you get that technique, okay, I'm multiplying this massive number by 1 digit, and then I'm multiplying this massive number by another 2-digit number, that's it. Once you're moving along each place value column, you just keep going. Neat presentation really does help. If you start to bunch these things up, if you start to not write one number per box, or if they start overlapping slightly, you're going to lose track of what you're exchanging. And if you drop an answer right at this last stage when you've done so much good learning for your multiplication here, it's just a bit sad, really, isn't it? And finally, organise yourself first, and these can quickly become a strength. So many children that I see, they see one of these and there's a bit of a moment where you think, I've got so much to do. If you take each of these little phases as a tiny little step, they're actually, none of them are too tricky. And what we go back to is my original point at the beginning is the tricky bit is having the times tables. If they're automatic and quick, everything is moving smoothly. There's no shortcut to knowing this, really. Just get your times table sorted, and then it's just a case of working the method like with anything else. Hopefully this helps. This is absolutely one of those methods that you're going to want to put time into because it has so many applications. I will do another video for something like ratio, for example, but ratio is such a small subject. Multiplication you're using through primary school and on forever, really. So it's one of those that we do want to put the time into. You get more marks and you're just going to get more mileage out of it. It's going to be really useful to you from start of schooling all the way through your life. So let's turn this weakness into a strength. Thanks for watching the video. Remember to like, subscribe, send it on to somebody who struggles with long multiplication. I'll let you into a secret. Before I started teaching year 5 and 6 again, I had to reteach myself how to do long multiplication. Maybe I needed a better teacher in the first place, but it can be tricky. I do get it, but stick with it. Follow the method, be organised, and it can be a strength of yours. See you all soon. Ciao.